You know, there's something deeply satisfying about watching raw timber transform into the lumber that builds America. What we're seeing here is a complete sawmill operation that represents the perfect marriage of traditional American forestry and cutting-edge Brazilian engineering from Mendes Maquinas. This isn't just any mill. It's a testament to how far we've come from the days when our grandfathers worked these same forests with hand tools and sweat. Let's start where every great piece of lumber begins, deep in the forest. The harvesting operation you're watching uses modern feller bunchers and harvesters, but the principle remains the same as it was 100 years ago. Select the right trees, cut them cleanly, and get them to the mill with minimal waste. These specialized machines can fell, delimb, and cut a tree to length in less than a minute. Compare that to the old days when a two-man crosscut saw team might spend an hour on a single large tree. The hydraulic arms grip the trunk with precision, and the chainsaw head cuts through even massive old-growth timber like butter. But here's what's interesting. Despite all this automation, there's still a skilled operator making split-second decisions about cutting angles and tree placement, just like the timber cruisers of old. Once the trees are down, they're loaded onto specialized logging trucks using hydraulic loaders. These aren't your typical flatbeds. They're purpose-built machines with adjustable bunks that can carry upwards of 40,000 pounds of raw timber. The loading process itself is an art form. Each log is positioned to maximize the load while maintaining proper weight distribution. Back in the 1950s and 60s, loading was done with cables and a lot of manpower. Now, one operator with a skilled hand can load a full truck in 20 minutes. Now, here's where things get really interesting. As these logs arrive at the mill, they enter a world of precision machinery that would have seemed like science fiction to the millwrights of the past. Mendes Maquinas, a Brazilian company that's been perfecting sawmill equipment since the 1960s, has become one of the premier manufacturers of complete mill systems. Their equipment is known throughout the Americas for its durability and efficiency, qualities that American mill operators have always valued. The first stop in any mill is the log deck and debarking station. What you're seeing is a Mendes debarker. Notice how those rotating rings of hardened steel teeth strip away bark with remarkable efficiency. This serves two purposes. It protects the saw blades from excessive wear, and it recovers the bark for use as mulch or biomass fuel. Nothing goes to waste in a modern mill. The logs are fed through automatically, with sensors detecting diameter and adjusting the pressure accordingly. A skilled operator monitors the process, but the system is largely automated, a far cry from the manual debarking stations where workers use spud bars and sheer muscle. After debarking, the logs move to the log sorting and positioning system. This Mendes setup uses a combination of hydraulic kickers and chains to orient each log perfectly for the primary breakdown saw. Here's a bit of mill wisdom that's been passed down through generations. The first cut is the most important cut. Get it right and you maximize yield. Get it wrong and you're leaving money on the table, or more accurately, in the sawdust pile. The primary breakdown saw you're watching is a Mendes horizontal band sawmill. These machines are the workhorses of modern sawmills, and this particular model can handle logs up to 36 inches in diameter. The bandsaw blade, a continuous loop of high-carbon steel with tungsten carbide teeth, moves at speeds exceeding 5,000 feet per minute. That's nearly 60 miles per hour of cutting edge moving through solid wood. The blade is thin, typically less than 1/10 of an inch, which means minimal kerf. That's the width of material removed by the cut. Less kerf means more lumber and less waste. But here's what really sets modern systems apart: laser scanning and optimization software. Before each cut, multiple sensors scan the log, creating a three-dimensional map. The computer analyzes this data in milliseconds, calculating the cutting pattern that will produce the highest value from that specific log. It accounts for taper, sweep, defects, and even internal characteristics that affect wood quality. The sawyer, and yes, there's still a skilled sawyer operating this system, can override the computer's suggestions, but more often than not, the optimization is spot on. As the primary breakdown saw slabs off the outer sections, the cant, that's the square or rectangular center section, continues down the line. This is where the Mendes gang saw system comes into play. A gang saw uses multiple blades mounted in a frame to make several cuts simultaneously. The cant passes through once and emerges as multiple boards already cut to standard dimensions. It's incredibly efficient. Where a single blade saw might take 4 or 5 passes to break down a cant, the gang saw does it in one. Time, as they say in the sawmill business, is lumber. Now let's talk about something that would have amazed the old-timers: the edger system. After the boards leave the gang saw, they still have irregular edges with bark and wane. That's where the edge of the board still shows the rounded surface of the log. The Mendez optimizing edger uses high-speed circular saws mounted on a carriage that can adjust position instantly. Those same scanning sensors that map the log now map each board, determining the optimal edge cuts to produce standard widths while maximizing yield. The whole process happens so fast it's almost a blur, but each board is being individually analyzed and cut to precise specifications. Here's a piece of history for you. Back in the 1800s, sawmills used a device called a moulay saw, a reciprocating vertical blade that moved up and down. A good moulay saw could process maybe 2,000 board feet in a 10-hour day. This modern system you're watching can process 2,000 board feet in about 15 minutes. That's not just technological progress, that's a revolution. The trim saws are next in line, and these are fascinating pieces of equipment. These Mendez optimizing trim saws cut the boards to standard lengths, 8, 10, 12, 14, or 16 feet typically. But again, there's optimization software at work. The scanner identifies defects, knots, splits, stain, or rot, and the computer determines where to make the trim cuts to maximize the value of each board. A board that might have a bad section in the middle can be cut into 2 shorter, clear pieces that sell for more than the full-length defective board would have. This kind of optimization has increased mill yields by 10 to 15% compared to the old days of fixed-length cutting. After trimming, the boards enter the sorting system. This is where the Mendez package includes automated lumber sorters with chains, kickers, and drop chains that route boards to different bins based on species, grade, width, length, and moisture content. In the old days, this was all done by hand, with lumber graders inspecting each board and physically moving it to the appropriate pile. Now, the grading is still done by trained personnel. You can't automate the human eye's ability to assess wood quality, but the physical sorting is handled by machinery that can move thousands of boards per hour. The stacking and banding system is the final step before the lumber either goes to the kiln for drying or ships out as green lumber. Modern Mendez stackers create precise packages with stickers, those thin strips of wood between layers that allow air circulation. The spacing is critical for proper drying, and the machine places them with mechanical precision. Automatic strapping machines then band the packages, and forklifts move them to storage or loading areas. What you're witnessing here is more than just wood processing. It's the continuation of an American tradition that's been refined and perfected over centuries. From the logger in the woods to the sawyer at the controls, from the millwright maintaining the equipment to the lumber grader assessing quality, this is skilled work performed by dedicated professionals using the finest equipment available. Mendez Maquinas has earned its reputation by building machinery that combines strength, precision, and reliability, exactly what American sawmill operators demand. Welcome to one of the crown jewels of American timber processing, the Weyerhaeuser Mill in Cottage Grove, Oregon. Now, if you're from the Pacific Northwest or you've been in the lumber business for any length of time, you know the Weyerhaeuser name carries weight. This company has been a cornerstone of American forestry since Frederick Weyerhaeuser bought his first timberland back in 1900. That's 125 years of experience in growing, harvesting, and processing some of the finest timber in the world. Cottage Grove sits in Oregon's Willamette Valley, and this region has been producing lumber since pioneers first arrived in the 1840s. The Douglas fir forest here became legendary among builders, straight, strong, and clear wood that built everything from clipper ships to the suburban homes of post-war America. The Weyerhaeuser facility we're looking at today represents generations of accumulated knowledge combined with state-of-the-art technology. The logs arriving at this mill come primarily from Weyerhaeuser's own managed forests. Here's something that might surprise younger folks. Sustainable forestry isn't some new concept that came along with the environmental movement. Weyerhaeuser has been practicing scientific forest management since the early 1900s, planting more trees than they harvest, managing for wildlife habitat, and ensuring that these forests will be producing timber for our great-grandchildren. Every tree you see arriving here will be replaced with seedlings that are already growing in their nurseries. The log yard at Cottage Grove is impressive in its organization. Logs are sorted by species, primarily Douglas fir, but also some hemlock and cedar, and by diameter class. This sorting happens as the trucks unload, with skilled operators using loaders to place each log in its designated area. It might look random to the untrained eye, but there's a sophisticated inventory management system at work here. The mill knows exactly how much of each timber type they have on hand, and can pull specific logs for specific orders. The debarking system here is a drum-style debarker, different from the ring debarker we saw earlier. The logs enter a massive rotating drum with interior knobs and protrusions. As the drum rotates, the logs tumble against each other and against the drum walls, and the bark literally falls off. It's less precise than a ring debarker, but perfect for high-volume operations like this. The bark gets collected and either burned for power generation. This mill produces much of its own electricity from biomass or processed into landscaping mulch. Remember, nothing wasted. What sets the Weyerhaeuser operation apart is the integration of their systems. After debarking, logs move on a continuous chain conveyor through a scanning station. Here's where it gets technical. The scanners use a combination of cameras, lasers, and X-ray technology to build a complete profile of each log. They're not just measuring diameter and length, they're detecting internal defects, grain patterns, and moisture content. This information feeds into their optimization software, which has been refined over decades of operation. The primary breakdown here uses a combination of band saws and circular saws depending on log size. For larger logs, and some of these Douglas firs can be 36 inches or more in diameter, they use a twin band saw system. Two band mills work in tandem, making parallel cuts to slab off the exterior, while a circular saw cuts through the center. It's faster than sequential cutting and produces excellent results on large timber. For smaller logs, a single band mill with automated log turning and positioning handles the job efficiently. One thing you'll notice about the Weyerhaeuser operation is the speed. This mill was designed to process volume, and it shows. Logs are moving through the system at a pace that would have been unimaginable 50 years ago. Yet despite the speed, the quality remains high. That's because Weyerhaeuser has invested heavily in their workforce training. The operators you don't see on camera have often been with the company for 20, 30, even 40 years. They understand timber. They can read grain, spot defects, and make split-second decisions that optimize yield. The gang saws here are massive pieces of equipment, capable of sawing through a cant in seconds. These saws use blades that are tensioned to incredible precision. We're talking about tolerances measured in thousandths of an inch. The blade speed and feed rate are constantly adjusted based on wood density, moisture content, and desired cut quality. It's a ballet of steel and timber performed at industrial speeds. The edging and trimming systems at Cottage Grove showcase Weyerhaeuser's commitment to value recovery. Their optimizing edgers and trim saws are integrated with the same scanning and decision-making software that maps the initial logs. Every cut is calculated to maximize value. A board that comes off the gang saw might have multiple possibilities. It could be edge cut to produce one wide board, or two narrower ones, depending on market prices and demand. The computer knows current prices for every dimension and grade and makes recommendations accordingly. The human operator maintains oversight, but the system is remarkably sophisticated. Here's something interesting about the Cottage Grove operation. they maintain flexibility. While they run standard dimensional lumber, your 2x4s, 2x6s, and so on, they can also produce specialty items like timbers, industrial cants, and export-grade lumber. This adaptability has kept the mill competitive through changing markets and economic cycles. Mills that couldn't adapt closed down decades ago, but Weyerhaeuser facilities like this one have thrived by staying current with technology while respecting traditional craftsmanship. The sorting and stacking systems here handle an enormous volume. Lumber comes off the trim saws and moves through automatic sorters that can handle dozens of different categories simultaneously. The stackers create packages that are strapped, tagged with radio frequency identification chips for tracking, and move to either the kiln drying buildings or the green lumber shipping area. The kilns themselves, though we're not seeing them in this clip, are computer-controlled environments where temperature and humidity are precisely managed to bring the lumber down to the optimal moisture content for its intended use. What you're witnessing at Cottage Grove is more than just efficient manufacturing. It's the embodiment of American industrial forestry at its finest. From sustainable forest management to high-tech processing, from skilled workers to sophisticated machinery, this facility represents the evolution of an industry that's been vital to American prosperity for generations. Now we're at the Rayonier facility in Aberdeen, Washington, where logs are transformed into something different. Engineered plywood panels that have been essential to American construction since their widespread adoption after World War II. Aberdeen sits on the Pacific coast in timber country that's been producing forest products since the logging boom of the 1880s. The logs arriving here are primarily second-growth Douglas fir and hemlock, harvested from managed forests throughout the Pacific Northwest. What makes plywood production different from lumber milling is that we're going to be peeling these logs into thin veneer sheets rather than sawing them into boards. It's a completely different process that requires specialized equipment. After debarking, the logs move to the conditioning vats, large heated water baths where logs soak for 12 to 24 hours. This softens the wood fibers and raises the wood temperature, making it easier to peel uniform veneer sheets. The temperature and duration depend on species, diameter, and time of year. It's knowledge accumulated over decades of plywood production. The heart of plywood manufacturing is the veneer lathe, and the system here is impressive. The log is mounted between massive chucks and rotated against a pressure bar and knife blade. As the log spins, a continuous sheet of veneer peels off, typically around 1/8 inch thick. It's like unrolling a paper towel, except this paper is solid wood spinning at high speed. The skill is in maintaining consistent thickness as the log diameter decreases with each revolution. These veneer ribbons are clipped into sheets, sorted by quality, dried in massive kilns, then assembled with grain directions, alternating to create the incredibly strong panels we know as plywood. The cross-grain construction makes plywood resistant to splitting and dimensionally stable, properties that made it revolutionary when it was first mass-produced in the 1900s and essential to modern construction today.